One more on multiplication. So again, hopefully you guys get the idea. But ooh, we got some ones. We have some restrictions, right? I like restrictions. Should we look at this graph and already know what the domain is really quick? All real numbers except x cannot equal 0. So how can we write that? Well, you know, let me actually go through this. How would we write that? Here's the number line. Here's 0. All real numbers except for 0. Does that look like a value of the graph? All real numbers except 0. Every other x value, this is the x number line. Every other value x on the number line works, except for 0. So we say, well, let's go from left to right. Every value all the way to negative infinity, all the way to 0 is defined. But 0 is not defined. That's why I have to use a parenthesis. And then I have to hop over 0. And then from 0 to infinity is defined. And then, if I want to, I could use the little union symbol to connect them. For some reason, the union symbol is like where everybody, I lose them. So then fine. Don't want the union symbol? Then don't use the union symbol. There's the domain. OK? Here, we have a domain restriction. This is x plus 2, or x equals 0. That's what makes the denominator 0. Greater than or equal to 0. So x has to be greater than or equal to negative 2. Can we graph that on a number line? Yep, negative 2. So let's look at the product first. Let me actually do the product. So that is going to be f of x times g of x. So that is going to be 1 over x times the square root of x plus 2. Ugh. Has anybody multiplied a fraction or fractional function times a radical before? No? Yeah. Well, can you multiply? This is really, it's a rational function, but it's really just a fraction, right? What happened? How do you multiply 1/2 times 4? What does that look like? What did I do? I multiplied numerator times numerator, denominator times denominator, right? This is really just a function over 1. Just multiply straight across. It's not any more complicated than what you guys have already done. There we go. Now, what is the domain? Now, again, when we look at multiplication, adding, and subtracting, we're finding the combination where the domain is defined for both functions. You have the answer or a question?
Yeah, the domain.
OK. So hold on, listen. So just remember, guys, the domain is where both domains are defined. Not just one. They both have to be defined. So go ahead.
It would be negative 2, which is included, to 0, which is not included, and then 0, still not included, to infinity.
Correct. And at each one of these intervals, would you guys agree that both of the graphs have a domain for that portion? Like, look at negative 3. Are both the graphs defined at negative 3? Nope, only one of them is. At 0, one function is defined for 0, but not the other one. So that's why when you're looking at the combination of functions, we're only looking for when they're both defined. OK? All right. So that, ladies and gentlemen, is addition, subtraction, and multiplication.